Close your eyes for a moment and imagine an invisible web everywhere around you, in your home, on your street, stretching across continents. This web is made of devices that are constantly listening, watching, and, well, learning about your world. It's a startling fact. In 2023, there were already 16.6 billion of these connected things globally. Now, here's where it gets really interesting. Just a few short years from now, by 2030, that number isn't just going to grow, it's projected to explode to an astonishing 40 billion. 40 billion connected devices. What does this exponential growth in the Internet of Things, or IoT, truly mean for you, for our homes, our cities, and even the very fabric of human society?
It's a profound question, isn't it? The scale of this transformation is just immense. It's quiet in some ways, but absolutely redefining our interaction with the physical world.
It truly is staggering. And when we talk about that scale, it immediately raises the question of how this pervasive connectivity is actually changing our world, doesn't it?
Absolutely. It touches everything.
That's precisely why, in this deep dive, our mission is to unpack the incredible reality of our connected world. We're going to journey from the foundational science that makes it all possible to the mind-bending possibilities that are already emerging, the surprising facts that challenge our assumptions, and crucially, the critical questions we must all consider. Because as our devices become ever smarter, more intertwined, and more deeply integrated into our lives, our understanding of them needs to evolve just as rapidly. So let's dig into this. When we talk about the Internet of Things, or IoT, it often sounds like something out of a science fiction novel,
Sure.
a massive complex concept that maybe only engineers could truly grasp.
Right, it can seem very technical.
But at its core, the fundamental idea is actually quite elegant in its simplicity. We're essentially talking about devices equipped with specialized sensors, processing power, and software. These components allow them to connect and exchange data, not just with us humans or with a traditional internet, but with other devices and systems over various networks.
And what's fascinating here, and maybe a bit confusing sometimes, is that the very term Internet of Things can be a bit of a misnomer. It's important we clarify that up front.
Oh, interesting. How so?
Well, many people assume these devices must be connected directly to the public internet to be considered IoT, but that's not necessarily true. The crucial point is that they just need to be networked and individually addressable.
Okay, networked and addressable, so not necessarily the big public internet.
Exactly. It means each device can be uniquely identified and communicated with within a specific defined network. That could be your home Wi-Fi, sure, but it could also be a private industrial network or, a global cellular network. This foundational concept allows for incredible versatility. Think of a smart thermostat in your isolated cabin, or maybe a complex sensor deep within a factory that only talks to local systems. The internet part refers more to the interconnectivity, the web of connections, rather than strictly the public World Wide Web itself.
That distinction is key. It opens up a lot more possibilities than just things connected to the cloud. And when you look back, it's incredible to think about how far we've come. The history of smart connections, what we might call the dawn of connectivity, actually goes back further than many people might imagine.
Oh, much further. Long before the internet as we know it even existed.
We're talking about early curiosities that really paved the way for this ubiquitous computing idea. For instance, imagine the academic halls of Stanford Artificial Intelligence Laboratory back in 1972. They had this rather whimsical but incredibly pioneering computer-controlled vending machine called the Prancing Pony.
The Prancing Pony, I love that name.
Right, and it wasn't just about dispensing cold drinks and snacks for cash. This machine was adapted to accept credit via a computer terminal. It sounds simple now, maybe, but it was a surprising, very early glimpse of a physical object being controlled and interacted with by a computer system in a totally new way.
Indeed, it laid a very practical foundation, a physical thing, controlled digitally. And building directly on that, just 10 years later, in 1982, Carnegie Mellon University took things a significant step further. They really pushed the boundaries of what was possible with early networking.
What do they do?
Their computer science department had a Coca-Cola vending machine that achieved a remarkable milestone. It became the very first ARPANET-connected appliance. ARPANET being, the precursor to today's internet.
Wow, a Coke machine on the ARPANET.
Exactly. And this wasn't just about selling sodas. The machine could provide real-time temperature and inventory status updates to researchers across the network. Think about that for a moment. A vending machine connected to this early network, providing live, actionable data about its internal state. Cold Cokes or not, how many left? It sounds quaint, but it truly was a pioneering smart device in its time. It demonstrated the power of remote monitoring and control, which are, well, core tenets of modern IoT. These early examples, seemingly disconnected, started us down the path.
It's funny how often innovation starts with something seemingly mundane, like a vending machine. And it wasn't long after these early experiments that visionaries started to formalize these burgeoning ideas, giving them names and frameworks that we still reference today. Mark Weiser, for example, published his incredibly influential 1991 paper, The Computer of the 21st Century. He wasn't just predicting faster computers.
No, his vision was much grander. He was envisioning what he called ubiquitous computing, or ubicomp, the idea that technology would seamlessly integrate into our environment, becoming so woven into the fabric of daily life that it would practically disappear into the background. Calm technology, he called it.
Calm technology, I like that. And then, in 1999, Bill Joy, a co-founder of Sun Microsystems, he presented his visionary Six Webs framework at the World Economic Forum. And he explicitly included device-to-device communication as a key foundational component of the future internet. He really saw those threads connecting everything, didn't he?
He absolutely did. And it was also in 1999, almost concurrently, that Kevin Ashton, while working at Procter & Gamble and later at MIT's Auto ID Center, independently coined the term Internet of Things.
Ah, so that's where the name came from. Kevin Ashton, 1999.
That's right. Though he often preferred the phrase Internet for Things, which perhaps even better captured his initial focus. He was looking at using radio frequency identification, or RFID tags, to manage individual items and supply chains. His vision was to imbue every physical object with a digital identity, making supply chains vastly more efficient. Know where every single item is automatically. The core idea, as it evolved from those simple networked vending machines to Ashton's RFID tags, wasn't just about linking traditional computers anymore.
Right, it was shifting.
It was shifting towards embedding short-range mobile transceivers, these tiny intelligent chips, into everyday objects, everything from a pallet of goods to maybe even the packaging itself. This enabled entirely new forms of communication, not just between people and things, but fundamentally between things themselves. This shift from human-computer interaction to machine-to-machine, or M2M, communication is absolutely crucial for understanding the current explosive landscape of IoT.
Okay, so things talking to things and enabled by these tiny embedded chips and networks. That clarifies the core concept. So if you're now picturing all these billions of devices, from smart toasters to industrial sensors, constantly collecting and sending data everywhere, how does it actually work on a technical level? It sounds incredibly complex, but you mentioned there's a structure to it.
Yes, there's a surprisingly elegant, generally accepted four-layered architecture that underpins virtually every IoT ecosystem. It helps to break it down. At the very bottom, forming the foundation, you have what we call the sensing layer.
Sensing layer. Okay, makes sense. That's the physical part.
Exactly. This is where the physical objects themselves reside, along with their crucial components. The sensors. Think of gas sensors in a factory, water quality sensors monitoring a river, or maybe moisture sensors in a smart garden system. This layer also includes actuators. Those are the components that actually do something based on the data, like turning off a valve, dimming a light, or starting a motor. This layer is essentially the eyes, ears, and hands of the IoT system, diligently collecting raw data from the physical world or acting upon it.
Got it. Sensors gather, actuators act. What's next?
Well, once that torrent of raw data is gathered from the physical world, it needs to be transmitted somewhere for analysis or action. That brings us to the next step up, the network layer.
The connections.
Right. This is where you find the diverse array of internet connections, Wi-Fi, cellular, Bluetooth, even wired connections, and various network gateways that manage traffic. Crucially, this layer also includes what are known as data acquiring systems, or DAS. The DAS acts as an intermediary. It aggregates all that raw, often analog data from the sensors.
Like translating it.
Pretty much. It converts it into a digital format that computers can understand and then efficiently transmits it to other devices, local servers, or cloud platforms. This layer is the crucial communication backbone, the nervous system allowing all those devices to connect and talk to each other, often across vast distances and varying network types.
Okay, sensing, then networking. So the data is collected and sent. Then what happens? This is where the smart part comes in.
Precisely. And then the true magic happens, or at least the analysis. That raw data, once transmitted, needs to be interpreted and made useful. That's the vital role of the data processing layer.
The brains of the operation.
You could think of it that way. This is the brain of the entire IoT system. Here, powerful processors, often utilizing cutting-edge artificial intelligence and machine learning algorithms, analyze that raw data, sometimes in real time. They don't just store it, they actively extract valuable insights, identify patterns, detect anomalies. Is this temperature normal? Is this machine vibrating oddly? This is also where critical functions like encryption and decryption happen, ensuring that your data is secure as it's being processed and understood. It's the intelligence within the machine, working tirelessly behind the scenes, turning mere bytes into actionable information.
Processing the raw stuff into something meaningful. Good. What's the final layer?
Finally, at the very top is the application layer. This is arguably what most users interact with directly and where the value of IoT truly manifests for them. These are typically the cloud-based applications, the dashboards you look at, the mobile apps on your phone, the control interfaces that take all the interpreted and processed data from the lower layers and deliver specific services and insights to you.
Like my smart home app.
Exactly like your smart home app. It adjusts your thermostat based on occupancy data processed lower down, or sophisticated security systems that send you alerts based on sensor triggers, or complex industrial control hubs that monitor factory output in real time. They take all the complex information, interpret it, and present it in a usable, intuitive way, allowing you to manage and interact with your connected world, often without even realizing the intricate layers working beneath the surface.
Oh, sensing the light, sending the data over the network, processing it to figure out the time of day you're from home, and then adjusting the smart bulbs through my app. That's the whole stack in action.
That's a perfect example of the entire architecture working together, quietly, seamlessly.
It's quite something when you break it down. So that layered architecture is quietly at work every single day, powering everything from our daily conveniences to critical industrial operations. But if that's how it works, then where is all this data going and what can it truly do in the grand scheme of things for our lives and our future? Let's get into the applications. Now, let's talk about where IoT is truly making waves. It's extending far beyond just, turning on your lights with your voice.
Yeah.
The breadth of applications is simply breathtaking. It offers a powerful glimpse into tomorrow, touching everything.
It really does. From our most personal spaces, our homes and health, to transforming entire industries and public spaces.
Let's start in the consumer realm with smart homes. They're rapidly evolving way beyond simple convenience, becoming truly adaptive living environments, aren't they?
They absolutely are. It's more than just automating lighting, heating, air conditioning, security systems, and cameras, though that's part of it. Imagine your home automatically saving energy, not just by knowing when rooms are empty, but by proactively making you aware of your usage patterns, maybe suggesting adjustments, empowering you to significantly reduce your carbon footprint.
So intelligence beyond just on-off commands.
Exactly. Common examples like Apple HomeKit, Amazon Echo, Google Home are familiar hubs, but we're seeing a significant rise in non-proprietary open-source ecosystems like Home Assistant. These platforms give users unprecedented control and customization, truly turning a house into a responsive, intelligent organism that you define. It's about more than convenience, it's about efficiency, personalization, and even environmental consciousness.
And it's not just about convenience for everyone. This technology is proving incredibly empowering for the vulnerable, particularly in elder care.
Hugely important area. What if assistive technology, like sophisticated voice control, could seamlessly aid those with mobility or sight limitations, allowing them much greater independence in their own homes?
That would be life-changing for many.
Or think about alert systems directly connected to vital medical implants or wearables. They could automatically notify caregivers or emergency services in an instant if something goes wrong. Imagine discrete sensors monitoring for medical emergencies like falls or seizures, providing immediate alerts and potentially life-saving interventions. This offers greater freedom, enhanced safety, and a significantly higher quality of life for seniors and those with disabilities, allowing them to age in place with dignity and security.
The potential impact there is just enormous. Okay, let's shift from the home to the wider world. How is IoT transforming industries and public spaces? This is where we hear terms like enterprise and industrial IoT.
That's right. And the impact is dramatic. Take the Internet of Medical Things, or IOMT. This encompasses a vast array of innovations. We're talking remote health monitoring devices, like continuous blood pressure and heart rate monitors, smart pacemakers, even consumer wearables like Fitbits that feed data directly to healthcare providers.
So constant monitoring outside the hospital.
Yes, and inside too. Think of sophisticated smart hospital beds that detect occupancy, monitor patient vital signs, and automatically adjust pressure points for optimal patient support and comfort. And this isn't just about better care, it's about cost efficiency too. Goldman Sachs, for instance, projected that IOMT could save the U.S. healthcare system over $300 billion annually.
300 billion. How?
By increasing revenue through better patient management and remote services, and significantly decreasing operational costs through efficiency and prevention. What's even more innovative, perhaps, is the rise of ultra-low-cost use-and-throw sensors, maybe fabricated on paper or e-textiles for point-of-care diagnostics, making healthcare more accessible and efficient even in remote areas.
Disposable sensors.
Wow.
Okay, shifting gears to our roadways. Smarter transportation systems. This is another huge area, right?
Absolutely. And it's undergoing a profound transformation. This isn't just about self-driving cars, though that's part of the vision. It's the seamless integration of communication, control, and information processing across vehicles, infrastructure, and users.
So everything talking to everything else on the road.
Pretty much. What if dynamic interactions between individual vehicles and traffic lights could optimize traffic flow across an entire metropolis, maybe reducing congestion significantly? Or what if intervehicular communication could predict and prevent accidents before they even happen by sharing sensor data and warnings instantly, saving countless lives?
That sounds like science fiction, but are we seeing bits of it already?
We are. We already see tangible examples of this with digital variable speed limit signs on highways, actively adjusting to real-time conditions like traffic density or weather. The ultimate vision is a fully coordinated network that makes travel safer, faster, and more environmentally friendly. Less idling, smoother journeys.
Makes sense. And in the industrial heartlands, the Industrial Internet of Things, or IIoT, what's happening there?
IoT is revolutionizing how factories, power grids, and logistical operations run. It's all about acquiring and analyzing vast streams of data from connected equipment and operational technology. The machines doing the work to regulate and monitor complex industrial systems with unprecedented precision.
So getting data directly from the factory floor machines?
Exactly. And this enables game-changing capabilities like predictive maintenance. Sensors can detect subtle signs of wear and tear on a machine, maybe a slight increase in vibration or temperature.
Before it breaks down.
Precisely. Allowing maintenance to be scheduled before a costly breakdown occurs, maximizing reliability and optimizing energy usage. No unexpected downtime. And a truly fascinating real-world example of IoT's unexpected reach is Toyota Tsusho's partnership with Microsoft Azure for fish farming.
Fish farming. How does IoT help there?
They're using AI and IoT-powered sensors to meticulously count fish, using computer vision, analyze water flow rates, and monitor oxygen levels in real time in these massive aquaculture pens. It helps optimize yields, reduce waste, and demonstrates how IoT's efficiency gains extend into sectors you might not immediately expect.
That Toyota Tsusho example really does illustrate how pervasive this tech is becoming. But it gets even bigger when we look at intelligent infrastructure and environmental watchdogs managing our public spaces.
Yes, think bigger scale. Imagine the bridges we drive over, the railway tracks our trains run on, or massive wind farms generating our power, being constantly monitored by embedded sensors. These sensors could detect minuscule structural shifts, maybe due to stress or corrosion, or efficiency deviations in a wind turbine long before they become critical issues, ensuring safety and optimizing maintenance schedules.
Proactive infrastructure management.
Exactly. And what if entire cities could use IoT for dynamic waste management? Optimizing collection routes based on real-time bin fill levels, saving fuel and time. Or for intelligent street lighting that adjusts brightness based on pedestrian or vehicle traffic, saving vast amounts of energy. Think of Songdo, South Korea, often cited as one of the first fully wired smart cities. It was designed from the ground up to operate with minimal human intervention, where everything from climate control to waste disposal is networked and optimized.
A city run by sensors almost. And the environmental side.
The environmental impact is equally profound. IoT devices are becoming crucial tools for comprehensive environmental monitoring. We're talking sensors deployed in remote forests to detect early signs of wildfires through heat or gas detection, or real-time monitors for air and water quality in urban rivers, providing immediate alerts for pollution events.
Giving us a real-time health check of the planet.
In a way, yes. They can track soil conditions in agricultural fields, optimizing irrigation and fertilizer use for sustainable farming, and even monitor wildlife movements in their habitats using tagged animals or sensor traps, revolutionizing conservation efforts. And on a more critical humanitarian note, What if resource-constrained, low-power IoT devices could form a distributed network to power earthquake or tsunami early warning systems?
How would that work?
By rapidly relaying seismic or oceanic data from many scattered, cheap sensors, they could radically improve emergency response times, potentially saving countless lives in vulnerable coastal regions. The potential for broad societal benefit here is truly immense.
It's incredible. And this reach extends even into, well, into the realm of national security, doesn't it?
It does. The military domain is actively leveraging IoT in what's increasingly being called the Internet of Military Things, IOMT, or sometimes the Internet of Battlefield Things, IOBT. This involves applying IoT technologies for reconnaissance, surveillance, and even direct combat operations.
Can you give an example?
Sure. Consider the Xaver 1000 system, developed by Camerotech. It's a portable device that uses advanced millimeter wave radar and AI for through-wall imaging.
See through walls.
Essentially, yes. And it provides real-time live target tracking. It's like having a form of X-ray vision on the battlefield, providing soldiers with critical situational awareness by showing exactly where threats might be located, even behind concrete walls.
That's quite the capability.
And these are not just theoretical applications. The U.S. Army Research Lab is actively pursuing the Internet of Battlefield Things, IOBT, to advance the theoretical foundations and practical applications of IoT for Army operations. They want to connect soldiers, vehicles, drones, sensors, everything into a cohesive, intelligent network. And DARPA, the Defense Advanced Research Agency, had launched its Ocean of Things project.
Ocean of Things, what's that?
It's a massive undertaking. They plan to deploy something like 50,000 floats equipped with passive sensors across vast ocean areas. These floats are designed to autonomously detect and track military and commercial vessels using various sensor data, providing unparalleled maritime domain awareness on a strategic scale. It's large-scale, strategic IoT for defense.
Wow. Okay, one more area before we move on. Product digitalization. This sounds different. It's not about big systems, but individual items.
Exactly. It pushes the concept of connectivity beyond the device itself, right down to the individual item or even its packaging. Think about the ubiquitous QR codes or NFC tags now found on products. These aren't just static labels anymore. They can enable access to dynamic digital content, transforming how we interact with physical goods long after purchase.
Like scanning a food package for recipes or allergy info.
Precisely. Or scanning a medicine bottle for dosage instructions or refill reminders. It's leading to concepts like the Internet of Packaging, where everything from food containers to medical vials can communicate its journey through the supply chain. This can ensure authenticity, help manage inventory automatically, and even engage consumers directly with personalized content or recycling instructions. It allows a product to communicate its origin, its story, and even its future directly to you, the consumer.
So the packaging itself becomes smart.
In a sense, yes. It becomes a gateway to digital information and services related to that specific item.
These applications certainly paint a picture of immense potential, highlighting just how deeply IoT is weaving into the fabric of our world. It really is becoming the unseen nervous system of modern society. But this transformation, this incredible magic of connectivity and insight, it doesn't just happen on its own, does it?
Not at all. It's thanks to increasingly sophisticated underlying technologies and, crucially, massive advancements in how we manage the sheer volume of data these billions of devices generate. That data is the lifeblood.
It truly is. All those sensors, all those billions of devices, they're constantly collecting information every second of every day. This leads us right into what we call the data deluge and its management. The raw data collected by IoT technologies about the physical world is, without exaggeration, the fuel of IoT. Without it, the whole system grinds to a halt. No insights, no smart actions.
Precisely. But here's the inherent challenge. Simply collecting data, no matter how much, isn't enough. The sheer volume creates a classic big data problem. The real complex work lies in meticulously cleaning, efficiently processing, and intelligently interpreting these vast amounts of raw, often messy, unstructured data.
So dealing with the sheer messiness and size of it all.
Exactly. And companies and organizations have to make strategic choices about where to store and process this information. Do they keep it on premises with their own physical servers? Do they leverage elastic cloud-based systems like AWS or Azure? Or increasingly, do they process it at the edge of the network?
Edge computing, meaning closer to the devices themselves.
Right. Processing data locally on the device or a nearby gateway before sending summaries or alerts upstream. Each approach has trade-offs. Cloud offers compelling advantages like lower initial hardware costs and incredible scalability, but it often raises significant security and privacy concerns because your data is leaving your local environment. Physical servers, though generally safer from a control standpoint, can be substantially more expensive to buy, maintain, and scale up. Edge computing can reduce latency and bandwidth use, but adds complexity. It's a constant balancing act.
And the why of all this meticulous data management. Why go to all this trouble?
Because it's absolutely critical for our connected future. It's what enables businesses and organizations to identify subtle patterns, emerging trends, and critical anomalies using sophisticated machine learning models and deep statistical analysis. This leads directly to informed, data-driven decision-making, transforming guesswork into precise action. Think about the profound business and technical benefits that IoT analytics unlock.
Okay, like what kind of benefit?
There are so many, and they span every sector. For example, consider optimizing efficiency. Imagine a global food and beverage company tracking the internal temperature of its refrigerated trucks in real time. If they get an instant alert when a unit malfunctions, they can prevent hundreds of thousands of dollars in spoilage due to power outages or mechanical failures.
Saving money and preventing waste. Makes sense.
Or think about improving safety in heavy industry. Maybe a construction company using sensors to monitor the stress levels on crane booms, predicting potential metal fatigue, and preventing catastrophic accidents before they occur. IoT analytics also provide real-time insights through streaming analytics, processing data literally as it's generated. This allows for immediate responses to changing conditions, adjusting factory settings on the fly, for instance.
Acting instantly, not just looking at reports later.
Exactly. And for scalability and accuracy, cloud deployment offers a pay-for-use model, making advanced analytics accessible to businesses of all sizes, not just giant corporations. Plus, analyzing data from many diverse sources significantly improves the overall accuracy and reliability of the insights derived. More data points usually mean better understanding. It's about making data not just abundant, but truly actionable and intelligent.
That real-time aspect, the ability to act immediately, is absolutely key. But for all this data to flow seamlessly, for all these devices to talk to each other, we need to talk about connecting everything. The unseen wireless and wired backbone that holds it all together. Looking at the latest 2023 figures, wireless technologies clearly dominate the IoT landscape, right? That's what most people think of.
They certainly do. Grab the headlines. Wi-Fi leads the pack, making up a significant 31% of all IoT connections globally. It's especially prevalent and preferred in smart homes, commercial buildings, and critical healthcare environments due to its high bandwidth and the fact that Wi-Fi infrastructure is often already there.
And it's getting better faster.
Definitely. What's truly notable is that 3/4 of all new Wi-Fi-enabled devices shipped in 2023 were based on the latest Wi-Fi 6 and Wi-Fi 6E technologies. These aren't just about raw speed, they offer vastly improved efficiency for handling many devices simultaneously, which is crucial for a crowded IoT environment like a smart home or office. And Wi-Fi 7 is already starting to ship, promising even lower latency and greater capacity, pushing the boundaries further.
Okay, so Wi-Fi is big. What else is dominant in wireless?
Following closely behind, Bluetooth accounts for about 25% of connected IoT devices worldwide. Here, Bluetooth Low Energy, or BLE, is the real game changer for IoT.
Low energy, so it's good for battery-powered things.
Exactly. It's specifically designed for battery-powered devices. It allows smart home sensors, wearable fitness trackers, asset tags, and similar devices to maintain reliable connectivity for months or even years on a single coin cell battery, consuming minimal power. Even the industrial sector is showing increasing interest in technologies like IO-Link Wireless, which is based on Bluetooth's robust technical standard, enabling short-range, highly reliable wireless communication right there on the factory floor.
Wi-Fi for bandwidth, Bluetooth for low power. What about connecting things over longer distances?
That's where cellular IoT comes in, and it now makes up nearly 21% of global IoT connections. This segment includes a range of technologies. Older 2G and 3G networks are gradually being phased out in many regions.
Making way for 4G and 5G.
Right. Making way for more modern 4G LTE-M and NB-IoT, narrowband IoT, and increasingly 5G. In 2023, cellular IoT connections grew a strong 24% year over year. This growth is largely due to the adoption of these newer, more efficient LTE-based technologies, which offer wide area coverage and excellent power efficiency for devices that need to operate far from Wi-Fi networks. Think smart meters, agricultural sensors, connected cars.
And 5G's role, is it overkill for simple sensors?
That's a great question. Full 5G is often overkill in terms of speed and cost for many IoT devices, but we're seeing the exciting introduction of 5G RedCap technology in 2024. RedCap to be more affordable and consume less power than full 5G while still leveraging 5G's robust security and reliability benefits. This is a potential game changer for IoT, allowing devices like long-lasting video surveillance cameras or industrial sensors, things that don't need gigabit speeds but require reliable wide-area connectivity to finally tap into the 5G ecosystem without the hefty cost or energy drain associated with full 5G.
Okay, so specialized 5G for IoT. That makes sense. Now, while wireless grabs all the headlines and dominates the popular imagination of IoT, you mentioned wired connections earlier. Are they still relevant?
Oh, incredibly relevant. It's easy to overlook the unsung heroes, the unseen wired connections. But they are absolutely foundational, especially in industrial settings, critical infrastructure, and even smart buildings. In 2023, there were approximately 0.7 billion wired IoT aggregation nodes. Think of these as central data transmission points, industrial gateways, routers, programmable logic controllers, PLCs, in a factory control panel.
So zero point 0.7 billion connection points. That sounds like a lot, but maybe not compared to the wireless numbers.
But here's the kicker, and this illustrates the hidden scale. These zero point 0.7 billion aggregation nodes connected to an astonishing 23.4 billion wired end nodes globally.
23 billion wired end nodes. Like what?
Everything from security cameras and smoke detectors hardwired into building systems, to essential medical equipment in hospitals connected via Ethernet, to countless sensors and actuators on factory machinery linked directly to those PLCs. It's a truly massive, often invisible network underpinning everything. Imagine a bustling factory floor. A single aggregation node in a control cabinet could easily connect to over 100 wired IoT end nodes, precision sensors, valve controls, environmental monitors. On average, the ratio is about 33 wired IoT end nodes per aggregation node in 2023. And that ratio is projected to increase to over 40 by 2030.
Why the increase?
It's driven by both the increasing complexity of industrial IoT deployments, more sensors, more control points, and the growing demand for reliable fixed connections in commercial and smart building environments where power isn't usually an issue and security or bandwidth might be paramount. Wired connections offer stability, high bandwidth, and often superior security in many critical applications, making them indispensable.
So wireless gets the hype, but wired is doing a huge amount of the heavy lifting, especially indoors and in industry. Beyond these established technologies, are there other exciting emerging connectivity horizons we should be aware of?
Yes, definitely. The landscape is always evolving. For instance, we're seeing something called LPWAN convergence. LPWAN stands for Low Power Wide Area Networks.
Like LoRa and Sigfox.
Exactly. Technologies like LoRa, Sigfox, and the cellular option NB-IoT are increasingly moving from being direct competitors to enabling strategic coexistence. This shift is enabling complex multi-connectivity solutions where devices might intelligently switch between networks based on availability or signal strength, or even leverage multiple protocols simultaneously. This ensures the best possible coverage, power efficiency, and data throughput for specific needs, maybe tracking livestock across vast remote farms or monitoring utility meters in dense urban canyons.
Combining the best of different worlds.
Right. And significantly, LEO satellite IoT is gaining tremendous traction. That's low Earth orbit satellites.
Like Starlink, but for small IoT data.
Sort of, yes. These LEO constellations offer extensive coverage, reaching areas where traditional cellular or Wi-Fi networks simply don't exist. Oceans, deserts, remote agricultural lands. And they do so with minimal signal delays compared to older geostationary satellites because they're much closer to Earth. This makes them incredibly useful for critical applications in agriculture, monitoring soil conditions in huge fields, maritime shipping, tracking containers globally, and logistics, tracking trucks in remote areas.
So truly global connectivity for small devices.
That's the promise. What's more, major players like Qualcomm and Sony Semiconductor are already working on integrating satellite connectivity directly into their standard LPWA chipsets. This means future IoT devices could have this powerful, ubiquitous connectivity built right in, potentially opening up completely new possibilities for remote data collection and control anywhere on the planet.
Built-in satellite connection. Wow. Okay, this brings us to a fascinating evolution within IoT, the growing intelligence within and around devices. It's not just about connection anymore, it's fundamentally about autonomous decision-making, right?
Absolutely. We're witnessing a clear shift towards what's called ambient intelligence and true autonomous control. The idea is that the objects themselves, rather than just acting as conduits for human commands or sending raw data, become the driving force for autonomous IoT actions. They start making decisions.
How do they learn to do that? Is that where AI comes in?
Precisely. This is where advanced artificial intelligence, particularly deep reinforcement learning, comes into play. It's a powerful AI technique that's fundamentally about training IoT devices to behave smartly by learning through continuous interaction with their environment.
Then by doing, essentially.
Kind of like that, yes. They receive feedback, essentially rewards or penalties for their actions, and over time they learn complex strategies to maximize these rewards. Think of a sophisticated smart home HVAC system. It senses the home's temperature, sure, but maybe it also learns your family's daily patterns, understands how external weather forecasts impact internal comfort, and then, through reinforcement learning, it intelligently decides when to turn on or off the heating or cooling to optimize both comfort and energy efficiency, all without explicit programming for every single possible scenario.
So the device itself figures out the best way to operate over time.
Exactly. The devices are essentially learning how to make optimal, intelligent decisions on their own, constantly refining their behavior based on outcomes.
And this capability leads to an even more advanced and frankly a bit mind-bending concept, the social Internet of Things, or SIoT. What on earth is that?
It's a fascinating theoretical and emerging practical framework. Imagine your smart devices aren't just isolated helpers, but actively social creatures. They don't just broadcast their own capabilities. They actively seek out and befriend or collaborate with other nearby devices to form temporary, dynamic teams to solve problems proactively, especially in emergencies.
Like devices teaming up.
Yes! Think of it like a flash mob of gadgets coordinating to assist you. Your smoke detector doesn't just blare an alarm. Instead, it instantly socializes with your smart home system. The system might then automatically call emergency services, guide you to safety by flashing pathway lights, unlock your front door for firefighters, maybe even shut off the gas line, all coordinated automatically without you lifting a finger. It's proactive, collaborative intelligence.
Wow, that's a whole different level of automation.
Or consider the future of transportation again. Imagine a scenario where vehicles, the roads themselves, with embedded sensors and traffic lights don't just communicate simple data points, but actively coordinate in real time for truly autonomous driving. If one vehicle encounters a sudden hazard, like black ice or debris, it instantly socializes that information, its precise location, the nature of the hazard with every other networked vehicle, traffic light controller, and maybe even roadside infrastructure in the vicinity.
So instant shared awareness across the network.
Exactly. They could then collaborate dynamically to reroute traffic safely around the hazard, alert authorities instantly in case of an accident, and ensure a seamless, safer flow of mobility for everyone. The SIoT envisages a world where devices understand their context, collaborate intelligently, and form these temporary social networks to offer smarter, more responsive services. It fundamentally changes not just how we interact with technology, but how technology interacts with itself, forming an adaptive, interconnected ecosystem.
This ever-growing network of connected devices and the vast amounts of data they generate are indeed transforming possibilities. It promises incredible convenience, unprecedented efficiency, and truly transformative insights. We've painted a picture of immense potential, haven't we? A world where devices quietly enhance our lives, boost industries, reshape defense.
The potential is definitely there, and it's exciting.
And there's always a but with powerful technology. Every technological leap, every powerful force, inevitably casts a shadow. And as these invisible threads weave themselves ever tighter around us, we absolutely must confront the hidden costs and the profound questions of trust, privacy, and control that demand our urgent attention. And that brings us squarely to the flip side of this amazing connected world, the shadows in the smart home, and really the smart everything. We need to critically unpack the prevalent concerns around privacy, security, and control that arise from this pervasive connectivity. What seems clear from research is that even expert users of smart home devices, people who are tech-savvy, report significant concerns about their privacy and security.
That's a critical and often paradoxical finding. What's frequently observed is what researchers sometimes call the privacy paradox.
The privacy paradox, what's that?
It's where users say they value privacy highly, but their actions don't always align. They tend to prioritize immediate convenience and the perceived benefits of a device over deeply engaging with complex privacy and security settings, even when they know they probably should.
So convenience wins out over privacy concerns, even for experts.
Often, yes. Despite their technical expertise, many users, even knowledgeable ones, admit they often lack a full, transparent understanding of how information truly flows within their smart homes. Where does the data go? Who sees it? How exactly is it used? This leads to a pervasive feeling of a lack of transparency and, frankly, a feeling of powerlessness. For many, it cultivates a kind of resignation. They just accept these concerns as an unavoidable part of the deal for the convenience offered.
Like a necessary evil.
Something like that. For instance, studies consistently show smart speaker users rarely utilize the privacy settings that do exist, like muting the microphone or deleting recordings, even though they actively express desires for features like an incognito mode or simple voice commands to temporarily stop the device from listening. They want control, but don't always use the controls they have.
It's fascinating how cultural nuances play a significant role here too, right? Shaping our comfort levels with data collection.
Absolutely. Studies, for example, clearly show that citizens in Germany tend to be far more privacy aware and inherently cautious about personal data collection than their counterparts in, say, the US or UK. Privacy traditions and regulations differ. This highlights that trust and data comfort aren't universal concepts, they're culturally shaped. But regardless of geography, what's consistently clear across cultures is that users universally express a strong, persistent wish for far more openness and greater control over how their data is gathered, used, and shared. They want clarity and they want agency. They want to be in the driver's seat.
Okay, so significant privacy concerns and a desire for more control. What about security vulnerabilities and real-world risks? Are those as top of mind for users?
It's interesting. Security concerns sometimes appear less prominent than privacy concerns in certain user surveys. This might be partly because expert users often proactively try to choose devices they perceive as secure, maybe from trusted brands, or they take active steps to secure their networks.
So they feel they've mitigated the risk somewhat.
Possibly, or maybe the threats feel less immediate or personal than privacy breaches. However, the real-life dangers are incredibly tangible and can be quite consequential. Consider a widely reported software bug in a popular brand of smart home locks that, astonishingly, led to a user's front door automatically opening during a power failure, and the manufacturer apparently hadn't issued a fix at the time of the report.
Your smart lock opening your door randomly, that's terrifying.
Exactly. This isn't just a theoretical threat about data. It's a direct physical security risk to your home and your safety, stemming from a software flaw in a connected device.
And here's where it gets really interesting, or maybe alarming, connecting to the broader, far more insidious threat landscape. The U.S. National Intelligence Council has issued stark warnings about this. They've stated that it would be incredibly difficult, if not impossible, to deny access to networks of sensors and remotely controlled objects by enemies, criminals, and mischief makers.
That's a chilling assessment from the intelligence community. They view IoT across the board as an increasingly rich source of data for surveillance and intelligence gathering, both foreign and domestic.
So what if a seemingly harmless smart device in your home, maybe a robotic vacuum cleaner mapping your floor plan, or a smart TV with a microphone, becomes an unwitting gateway for persistent surveillance?
It's a valid concern. There have been alarming reports, for example, from Reuters, detailing how Tesla workers apparently shared sensitive, sometimes highly personal, images and videos recorded by customer cars, things recorded inside garages, or even embarrassing situations. It's a stark example of how deeply personal data can be exposed through these connected devices, often without the user's knowledge or explicit, informed consent, sometimes just due to poor internal controls or misuse by employees.
That Tesla example is deeply unsettling. And on a larger scale, what about coordinated attacks using these devices?
A chilling, large-scale example that really underscored the collective risk of insecure individual devices was the Mirai botnet attack back in 2016. That was a watershed moment.
Mirai? I remember hearing about that. What happened exactly?
It demonstrated how hundreds of thousands of compromised IoT devices, largely inexpensive consumer devices like DVRs, webcams, and digital cameras that were shipped with default, easily guessable passwords that users never changed, could be weaponized. They were marshaled into a vast botnet, a network of infected machines controlled by attackers, to launch massive distributed denial of service or DDoS attacks. They flooded target servers with junk traffic.
And who did they target?
One major target was the DNS provider DIN. By overwhelming DIN servers, the attack effectively crippled major internet services that relied on DIN, taking down popular websites like Twitter, Netflix, Reddit, Spotify, and CNN for large parts of the internet for hours. It highlighted unequivocally that one insecure device in your home doesn't just put you at risk, it contributes to a much larger systemic threat to the entire global internet infrastructure. We're all connected, for better or worse.
So my cheap smart plug could be part of an attack taking down major websites.
Potentially, yes, if it's insecure and gets compromised. Furthermore, shifting back to industry, experts in manufacturing are deeply worried about data security for protecting machine technology from international competitors. With increased interconnectivity on the factory floor, industrial espionage through hacked IoT systems becomes a growing, serious concern, stealing trade secrets or disrupting production.
Wow. Okay, beyond the huge privacy and security risks, what about the practical challenges of just using all these different devices? You buy a smart light from one company, a thermostat from another, a lock from a third.
Ah, yes, you've hit on what the brilliant computer scientist Michael Littman famously coined the basket of remotes problem. It speaks to a massive and persistent fragmentation issue within the IoT world.
Basket of remotes,
Yeah.
meaning too many apps and controls.
Exactly. The sector suffers from significant platform fragmentation. You have an overwhelming variety of hardware using different chips, different software stacks, different communication protocols, and often locked into proprietary ecosystems. This makes it incredibly difficult to develop consistent applications or user experiences that work seamlessly across different brands and systems.
It's a usability nightmare.
It truly can be for many users. You have a bewildering array of wireless protocols just for the smart home: Bluetooth, Wi-Fi, Zigbee, Z-Wave. Then for wider areas, LoRa, Sigfox, NB-IoT, Cat-M1. Each has its own advantages, disadvantages, and unique support ecosystem. They don't always play nicely together, as Littman pointed out with his analogy. If users need to learn different interfaces for their vacuums, their locks, their sprinklers, their lights, and their coffee makers, it's tough to say that their lives have been made any easier. This isn't just an inconvenience. It's a genuine barrier to adoption for many people who aren't tech enthusiasts.
It feels like there are a million different terms for this stuff, too.
Oh, absolutely. There's a veritable terminology zoo. You hear IoT, IoE, Internet of Everything, industrial internet, pervasive computing, ubiquitous computing, cyber physical systems, M2M, machine-to-machine, web of things. Many overlapping, sometimes redundant terms. It makes it incredibly hard for even experts to keep up with the nuances, let alone the average consumer trying to figure out what product to buy.
Okay, so fragmentation and jargon are big hurdles. This leads directly to another critical and deeply concerning issue for consumers: the shadow of obsolescence and control. What happens when the company behind your smart device decides to, well, turn it off?
This is a huge issue. What happens when a company can remotely brick your device, render it completely useless by simply disabling the central servers it relies on, or by pushing forced software updates that deprecate core functionality?
Can they actually do that? Just turn off something I bought?
They can, and they have. A notorious example often cited is when Nest Labs, which is owned by Google, acquired a smart home hub company called Revolve back in 2014. Despite Revolve having explicitly promised its customers a lifetime subscription to its services when they bought the hub, Nest Labs unilaterally decided to shut down Revolve's central cloud service a couple of years later.
And what happened to the hubs people owned?
They became completely inoperable overnight. Expensive smart hardware turned into worthless plastic bricks because the cloud brain they needed to function was switched off.
Even though they were promised lifetime service, that seems fundamentally unfair.
It caused a huge outcry, understandably. This incident and others like it involving products from various companies raise incredibly critical questions about who truly owns a device once you've purchased it. What fundamental control do you, the buyer, retain after money has changed hands? It feels like a profound erosion of traditional ownership, especially concerning for devices that become central to your livelihood, like smart farming equipment, your home security, smart locks, or even your physical safety medical devices.
It shifts the power entirely to the manufacturer, even after the sale.
It certainly can. And beyond this direct control issue, there's the environmental angle. The sheer staggering number of semiconductor-rich IoT devices being manufactured billions upon billions, and they're often relatively short lifespans, due to rapid innovation or planned obsolescence, raises serious environmental impact concerns.
All that electronic waste.
Exactly. These devices are often laden with heavy metals, toxic chemicals from batteries and circuit boards, and complex embedded components all fused together. This makes proper recycling extremely difficult and expensive. Many ultimately end up in landfills or are incinerated, leaching harmful substances or releasing greenhouse gases. It leads to significant questions about the true lifetime environmental footprint of this connected revolution and our collective digital waste problem. Are we creating mountains of toxic e-waste in the name of convenience?
That's a sobering thought. The convenience is appealing, but the potential downsides, privacy, security, fragmentation, loss of control, environmental impact, are significant. These challenges are certainly huge, demanding our immediate attention and proactive solutions. But they also highlight the urgent need for robust solutions, industry-wide standards, and a much more thoughtful, user-centric approach to how we design, deploy, and interact with our increasingly connected future. It feels like a call to action for everyone involved, manufacturers, regulators, and us users. So we've identified the problems, the potential pitfalls, and the profound questions raised by our connected world. It can feel a bit overwhelming. Now let's talk about charting the course forward. What are the concrete solutions, standards, and the future landscape we should be aiming for to mitigate these risks and maximize the benefits? What do the experts say we actually need?
Well, based on in-depth interviews with expert users, there are clear desired mitigation strategies that emerge quite consistently. For instance, the overwhelming majority of these knowledgeable users desire far more granular control over their data.
More control seems to be a recurring theme.
Absolutely. And they express a strong sentiment that device manufacturers simply aren't doing enough right now to provide that transparency and control. They feel the burden is unfairly placed on the user to figure things out.
What kind of solutions are they suggesting?
That sentiment about user empowerment is absolutely key. It's about shifting the balance of power back towards the individual. In one study looking into this, several participants explicitly suggested open source solutions as a powerful path forward.
Open source. Like open source software. How would that help with hardware?
It applies to the software running on the hardware and the cloud platforms they connect to. The belief is that open source fosters trust because the code can be reviewed by the community. Bugs can be found faster, security holes patched collaboratively, and there's more transparency into how devices truly function and manage data, rather than it being a black box.
So, transparency through community involvement.
Exactly, and tied directly to this is the desire for robust community support. The idea of users sharing useful privacy settings they've discovered, publishing warnings about vulnerable products they've encountered, and maybe even creating community-curated databases for product security and privacy ratings, like a crowdsourced safety guide.
Sharing knowledge to protect each other.
Right. While some users might prefer a simple set-it-and-forget-it approach, many technically inclined users want that collaborative knowledge base and peer-driven accountability for manufacturers.
What about understanding where the data is actually going? That seemed like a big concern.
Yes, and another incredibly insightful suggestion was for outbound traffic analysis tools. Imagine an intuitive dashboard, maybe an app or part of your router software, that provides you with a holistic, real-time overview of all the data flows leaving your smart home devices.
Like a network monitor specifically for IoT.
Precisely. It would essentially inform you about their network behavior, what data they're sending, where it's going, which servers, which countries, how often, giving you visibility into what's happening under the hood. But crucially, and this was emphasized by participants, any such solution must prioritize usability. As a couple of experts specifically highlighted, a user-friendly, intuitive design is a non-negotiable prerequisite. It can't just be technically sound. It has to be easy for everyone to understand and use, not just a cybersecurity expert. Otherwise, it won't get adopted.
Makes perfect sense. Technical solutions without usability are useless for most people. Any other suggestions?
Yes, there was also a strong call for easily accessible device recommendations. Perhaps something simple like a traffic light system, green for secure, yellow for potentially concerning, red for known dangerous devices, providing clear guidance to consumers before they purchase something, helping them make informed choices up front.
A kind of safety rating for smart devices.
Exactly. And importantly, participants felt that any security or privacy solutions implemented should allow for full functionality, meaning security measures shouldn't significantly limit or break the existing useful features of the device. This aligns perfectly with the well-established privacy by design and security by design principles, where privacy and security are baked into a product from its inception, integral to its function, rather than being bolted on as an afterthought or compromising usability.
Build it in securely from the start.
That's the ideal. And finally, perhaps most fundamentally, there's an explicit desire voiced by users for widespread education. People want clear, accessible educational resources on data privacy, IoT security risks, and best practices, empowering them with the knowledge and tools to make informed decisions rather than feeling overwhelmed, powerless, or resigned to the risks.
Knowledge is power, as they say. This desire for transparency, control, and education leads us naturally to the crucial role of regulation and standards. Is anything happening on that front? Are governments and industry stepping up?
Yes, there's definite movement, though some argue it's not fast enough or comprehensive enough yet. Governments and industry bodies around the world are certainly recognizing the urgency of these issues. The U.S. Federal Trade Commission, FTC, for example, way back in 2015, issued foundational recommendations for IoT companies. These included implementing defense-in-depth security practices like strong encryption for data security both in transit and at rest.
Defense in depth, multiple layers of security.
Right. They also emphasized ensuring meaningful user choice and providing clear information for data consent, what data is collected, why, how it's used, who it's shared with. And critically, they pushed for data minimization.
Data minimization. Collect only what you need.
Exactly. Only collect the data that is truly necessary for the device's functionality and retain it only for limited, defined periods, then securely dispose of it. Don't hoard data just because you can.
Are these just recommendations or are they becoming law?
They are starting to translate into tangible legislation in some places. California's pioneering SB 327 law, which went into effect in 2020, is a key example. It legally requires manufacturers of connected devices sold in California to equip them with reasonable security features right out of the box.
What counts as reasonable?
Well, the law suggests things like unique default passwords for each device instead of universal ones, or forcing the user to set a password on first use. It puts the onus on the creators to build in basic security from the start. It's a step. Beyond government regulations, numerous influential alliances and standards organizations like the IEE, IETF, ITUT, 1M, 2M, and 3GPP, which handles cellular standards, are actively working on developing common, interoperable standards for IoT connectivity, data formats, and security protocols.
Trying to tame that fragmentation problem.
Exactly. And a major collaborative effort specifically focused on the smart home fragmentation issue is Project Connected Home over IP, now known officially as Matter.
Matter. I've heard of that. Big names involved.
Huge names. It's backed by industry giants like Amazon, Apple, Google, Comcast, Samsung SmartThings, the Zigbee Alliance, now the Connectivity Standards Alliance, and hundreds of other companies. The explicit aim of Matter is to unify the fragmented smart home ecosystem by creating a single, open, royalty-free connectivity standard built on proven technologies like IP, Wi-Fi, Thread, and Bluetooth LE. The goal is that devices from different brands carrying the Matter logo will just work together seamlessly, finally tackling that basket of remotes problem head on.
That could be a game changer for consumers if it really takes off. Okay, moving beyond just physical products and standards, we're seeing this broader trend of the everything as a service model, or SaaS. How does that fit into the IoT picture?
IaaS is fundamentally reshaping how we consume and interact with technology across the board, and it has huge implications for IoT. It's the concept of accessing services and applications over the internet upon request, essentially renting outcomes instead of owning assets. It builds directly on the familiar cloud computing models like software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, which many businesses already use.
But now it's expanding beyond just software.
And expanding rapidly into almost every domain imaginable. We're now seeing hardware as a service, HaaS, where you subscribe to physical devices, maybe paying per use or per month rather than buying them outright. Think jet engines billed by flight hours or medical scanners billed per scan. There's also communication as a service, CaaS, for integrated communication platforms, desktop as a service, DaaS, for virtualized workspaces accessible from anywhere, and security as a service, SECaaS, offering cloud-based cybersecurity monitoring and protection.
So as a service for almost anything, how does this directly impact specific IoT sectors?
It has a truly direct and transformative impact. Take healthcare again. Healthcare as a service, HaaS, is leveraging IoT sensors and wearables to offer things like 247 remote health monitoring subscriptions, feeding continuous data to AI platforms that can predict potential issues. It also enables online consultations, medicine and lab sample delivery services integrated with monitoring data and constant, secure cloud-based access to medical records for both patients and providers. This makes medical care profoundly more data-driven, personalized, continuous, and patient-centric, moving healthcare beyond episodic clinic visits.
Paying for health outcomes or continuous care, not just doctor visits.
That's the idea. Or consider transportation as a service. TACE. This includes everything from existing car-sharing services like Zipcar or ride-hailing like Uber and Lyft to the broader vision of autonomous mobility services. Uber, for example, has had ambitious plans exploring concepts like flying taxis and potentially using self-driving vehicles in the future. These models aren't just about consumer convenience, they also promote significant ecological benefits by optimizing resource use, potentially fewer individually owned cars sitting idle, leading to less congestion, less land needed for parking, and more efficient overall vehicle utilization.
So what are the big advantages driving this ZaaS trend in IoT?
The overarching benefits are quite compelling for businesses and sometimes consumers. There's incredible scalability, easily scale services up or down based on demand. There's significant cost and time effectiveness, often shifting from large upfront capital expenditures, buying equipment, to more predictable operational expenditures, monthly subscriptions. This allows companies to focus on their core competencies instead of managing complex infrastructure. It often provides access to consistently high-quality services with the latest technology managed by experts, and potentially it leads to better customer experiences through personalization and data-driven service delivery.
Sounds pretty good. What's the catch? What are the drawbacks?
Well, it's definitely not without its profound drawbacks and new kinds of risks. Major concerns revolve around the increased reliance on third-party providers for critical functions. What happens if that provider goes out of business, gets acquired, or has a major outage? This then raises fundamental questions about personal data security and the potentially catastrophic risk of massive data loss or privacy breaches if the service provider systems are compromised. Your data is now in their hands.
You lose direct control over your data and the service itself.
Exactly. This also brings up thorny legal and ethical questions about control over business-critical data and sensitive personal information when you are essentially relying entirely on a service provider for vital operations, rather than maintaining physical ownership and direct control over the systems and the data they generate. Who is ultimately responsible if something goes wrong? It complicates things.
So, convenience and scalability versus control and security risks. A difficult trade-off. Now, despite the incredible promise and the undeniable innovation we've discussed, the path to a fully integrated, truly intelligent IoT world isn't exactly smooth. It faces significant challenges in adoption and management, right?
Yes, there are definitely headwinds and hurdles. We're still navigating economic uncertainty in many parts of the world. Continued cautious enterprise spending due to persistent inflation, higher interest rates, and ongoing geopolitical conflicts creates investment uncertainty, making some companies hesitant to commit to large, transformative IoT projects right now.
Money's tight, so big new projects get paused.
That's part of it. And while the chipset supply chain situation has shown some improvement since the peak of the pandemic-induced crunch, lead times for many specialized chips remain stubbornly high compared to pre-COVID levels. Despite massive investments in new semiconductor fabrication plants, like TSMC's planned factory in Dresden, Germany, targeted for 2027, it may still take many years until supply truly catches up with the rapidly growing demand for the incredibly diverse array of specialized, often low-power chipsets needed for various IoT applications. This directly impacts the pace and scale of IoT device deployment.
Still hard to get the specific chips needed, even now. What about companies themselves? Are they ready?
That's another significant barrier. Organizational readiness. Many companies, frankly, lack the internal organizational capabilities, the right skill sets among their staff, and the robust digital processes required to fully capture the opportunities presented by IoT. It requires changes in how IT and operations technology, OT teams, work together, for instance. Some companies are adopting a wait-and-see approach, holding back on major investments until market dynamics become clearer, certain standards mature, or perhaps regulatory requirements force their hand.
This cautious approach, or maybe lack of readiness, can lead to setbacks, can't it? I remember hearing about IoT projects failing.
Yes, unfortunately, project failures or stalls are quite common. Some reports suggest that a staggering 70–75% of enterprise IoT deployments get stuck indefinitely in the pilot or proof of concept stage. They never scale up to full production.
Why do they get stuck? Is the technology not working?
It's usually not primarily a technical failure. More often, it's due to a fundamental lack of comprehensive business planning upfront, a failure to clearly define the value proposition, or an inability to integrate the IoT solution effectively into existing business processes and workflows. It signals a desperate need for new project management approaches tailored to IoT, maybe involving separate R&D phases to de-risk the technology, and crucially, more interdisciplinary project managers who can bridge the often wide gap between IT departments, operational teams on the ground, and overall business strategy. You need someone who understands all sides.
Getting pilot projects to scale seems like a major hurdle. What about funding for new ideas?
That's facing challenges too. Compounding these issues, there's been a noticeable decrease in IoT startup funding recently. One analysis showed a dramatic 45% reduction in global venture funding for IoT startups in Q1 2023 compared to Q1 2022. This signals a clear market consolidation phase where investors are becoming more selective, and it's a more challenging environment for nascent innovators to secure capital.
So harder for new IoT companies to get started or grow.
It seems that way currently. And perhaps the most overarching, persistent challenge across the board is the acute digital talent shortage. There's a global war for digital talent, as some call it. There is extremely high demand and not enough supply for professionals skilled in critical areas like IoT architecture design, cybersecurity for connected systems, artificial intelligence and machine learning implementation, edge computing development, and 5G network deployment and management.
Can't build it if you don't have the people.
Exactly. Without enough skilled professionals to design, implement, manage, and secure these increasingly complex systems, the pace of innovation and widespread deployment can be significantly hampered. It creates a bottleneck that affects the entire industry's potential growth.
It's clear that despite these very real hurdles, the economic cautiousness, the supply chain complexities, the organizational growing pains, the project scaling issues, and the talent gap, the overall momentum for a truly connected world seems undeniable.
The underlying drivers are very strong.
The vision of a truly intelligent, interconnected future continues to drive innovation at an incredible pace, pushing us forward into uncharted technological and societal territory, warts and all. So as we wrap up this deep dive, it feels like we've covered a huge amount of ground. We've journeyed from those earliest, almost quaint, connected vending machines.
The prancing pony and the Coke machine.
Right. All the way to a world realistically looking at potentially 40 billion smart devices within just a few years. We've explored how these invisible threads are meticulously weaving themselves into every single aspect of our lives, from the quiet conveniences of personal home automation and genuinely life-saving advancements in healthcare, to the profound efficiencies transforming industrial operations, and even the strategic innovations reshaping military capabilities.
The breadth of application is truly staggering when you lay it all out.
It is. We've really seen the incredible potential for progress, the immense benefits that data-driven insights can bring, and the intricate layered architecture sensing network processing application that makes it all possible, often completely unseen by the end user.
But just as importantly, I think, we've squarely faced the critical challenges that demand our attention and really our collective action. The persistent complexities surrounding personal privacy in an always-on, always-sensing world. The tangible risks of growing security vulnerabilities that affect not just individuals, but the stability of the internet itself.
Yeah.
The ongoing frustrations of technological fragmentation making things harder to use.
And those profound questions around data ownership, who really owns my data, who controls my device, and the unsettling reality of intentional obsolescence, where perfectly good hardware can be rendered useless by a remote decision.
Right. These aren't just abstract technical issues. They are deeply human concerns that impact our autonomy, our sense of control, our safety, and our fundamental relationship with the technology that increasingly surrounds us.
Exactly. The promise of a smarter, more efficient, more convenient world is immense, no doubt about it. But the trade-offs, the risks, and the responsibilities that come with it are equally real and pressing. We can't ignore them. So, as our world becomes increasingly smart, as our devices become ever more connected and intelligent, maybe the final thought for everyone listening is, what does it truly mean to be well-informed when the very concept of data ownership is being actively rewritten before our eyes?
That's a powerful question. How do you stay informed and retain agency?
How will you ensure that the compelling convenience of a connected future doesn't come at the unforeseen cost of your personal control, your privacy, or even your security? And perhaps most importantly, what proactive role will you play as a consumer, as a citizen, maybe as a creator, in shaping the ethical and secure evolution of the Internet of Things as it irrevocably continues to change our world?